Hello friends, welcome back to Positive Approach. This is Nitesh Bharatwaj. As you all know, we are discussing about our unit number 4, work, power and energy. We already discussed this work and energy. So today's our topic is power. First of all, we will discuss some important key point of this chapter, and after that we will do some numerical on the basis of this formula. So without wasting any time, let's start. What is power? What is power? Power is the rate of doing work. It is denoted by W by T. A power is also a scalar quantity. Like work and energy, power is also a scalar quantity and its dimensional formula is ml square T minus Q. Dimensional formula of power is ml square T minus Q. And its SI unit is, SI unit of power is watt. SI unit of power is watt, and keep in mind 1 joule, which is the unit of work. 1 joule is equal to 1 watt. 1 joule is equal to 1 watt, and 1 kilowatt is equal to 10 raised to power 3 watt. 1 kilowatt is equal to 10 raised to power 3 watt. And next key point is 1 horsepower. 1 horsepower is equal to 746 watt. Keep in mind 1 horsepower is equal to 746 watt. And the energy consumed by home appliances, for example bulb, the energy used by these home appliances can be measured in kilowatt per hour. Can be measured in kilowatt hour, and 1 kilowatt hour is equal to 3.6 into 10 raised to power 6 joule. And 1 kilowatt is 3.6 into 10 raised to power 6 joule. Now, power and energy relation. What is power? Power is equal to work divided by time. Okay, we know that work is equal to energy. So power is energy divided by time. What does this imply? This implies energy. Energy is equal to power into time. Energy is equal to power into time. This is all about power. Now, power in terms of force and velocity. There is also expression of power in terms of force and velocity. We know that what is power? We know that power is work done divided by time. And what is work done? Work done is force into displacement divided by time. Now we know that what is displacement over time? Displacement over time is velocity. Therefore, power is given by force into velocity. I hope this expression is clear to you. And there is also a relation between power and kinetic energy. Then power is equal to kinetic energy divided by time, ddt of kinetic energy. I hope this relation is also clear to you. Now we will discuss about elastic collision. There are 3 types of collision: perfectly elastic collision, inelastic collision and perfectly inelastic collision. Okay, so linear momentum is conserved in all cases. Keep in mind, linear momentum is conserved for perfectly elastic collision. It is also conserved for inelastic collision. It is also conserved for perfectly inelastic collision. So linear momentum is conserved for all type of collision. Okay, and kinetic energy. Kinetic energy is conserved for perfectly elastic collision. Perfectly elastic collision. And it is not conserved for inelastic and perfectly inelastic collision. So keep in mind, linear momentum is conserved for all type of collision and kinetic energy is conserved only for perfectly elastic collision. I hope these points are clear to you. Our next key point is force of interaction in an elastic collision. Force of interaction in an elastic collision is conservative in nature. Force of interaction in an elastic collision is conservative in nature, and force of interaction in inelastic collision is non-conservative in nature. In elastic collision it is conservative, and in inelastic collision it is non-conservative. Now, coefficient of restitution, which is denoted by E, which is 0. Coefficient of restitution E is equal to 0 for inelastic collision and for perfectly inelastic collision, and E is equal to 1 for perfectly elastic collision. Coefficient of restitution, which is given by relative velocity of separation divided by relative velocity of approach, it is equal to 0 for inelastic collision and for perfectly inelastic collision, and it is equal to 1 for perfectly elastic collision. And this perfectly elastic collision is a rare physical phenomena. It is a rare physical phenomena. Perfectly elastic collision is a rare physical phenomena. And variation of mass and velocity. Our next key point is variation of mass and velocity is given by this expression m is equal to m naught divided by under root of 1 minus v square over c square. These all expressions are very important because in examination numerical can be asked on the basis of these expressions and these formulas. So these all expressions are very important for examination point of view. This is the variation of mass and velocity given by m is equal to m naught under root of 1 minus v square divided by c square. Our next key point is energy of a body is independent of a time. Energy given by, what is energy? Energy in term of power, it is given by power into time. So energy of a body is independent of time. Energy of a body is independent of time, where power is dependent of time. Where power is dependent of time. Keep in mind. Now velocities of two bodies after collision are velocities of two bodies, where v1 is given by 2m2u2 plus u into m1 minus m2 divided by m1 plus m2, where m2 is the mass of second body, m1 is the mass of first body. Okay, and u1 and u2 are the velocities before collision, and v1 v2 is the velocity after collision, and these are the velocities of two bodies after collision, where v1 is equal to 2m2u2 plus u m1 minus m2 divided by m1 plus m2. Our next key point is gravitational force does positive work on body when body falls downward. As we earlier discussed in our this topic of work, when a body falls under the effect of gravity, the gravity done here positive work. Okay, and negative work when body raise upward. When we throw a object vertically upward, then there is a negative work done. Our next key point is area under acceleration displacement graph of a body. Area under acceleration displacement graph of a body is equal to change in kinetic energy of a body. Area under displacement and acceleration of a body is given by area under acceleration displacement graph of a body is equal to change in kinetic energy of a body. So change in kinetic energy of a body is given by area under acceleration and displacement. Our next key point is mechanical energy of a body is conserved if conservative force acts on it. Yes, mechanical energy of a body is conserved if conservative force acts on it. Our next key point, two bodies of equal masses interchange their velocity after elastic collision. If there is a elastic collision, for example, if there is a elastic collision, then the velocity, then this velocity is interchanged by this object after collision if they have equal masses. Our next key point, can scalar product of two vector can be negative? Yes, scalar product of two vector can be negative if the angle between them is theta is greater than that of 90 degree. The scalar product of two vector A and B is also negative if there is the angle greater than that of 90 degree. And keep in mind, potential energy of a body is positive as well as negative. Potential energy of a body is positive as well as negative, but kinetic energy of a body is always positive. Kinetic energy of a body is always positive. Our last but not the least point is a collision is one dimensional called head-on collision. Those collisions that are one dimensional in nature are also called head-on collision. These are the main important key point of our topic power. Now let's do some important numerical of power topic. Our first numerical is a 40 kg child run up a flight stair 4 meter high in 2 seconds. Calculates its power. A 40, what is the mass of the object? Here object is a child where mass is 40 kg. Mass is 40 kg and run up a flight stair of 4 meter height where height is equal to 4 meter and time is 2 seconds. We have to calculate this power. We know that the what is formula of power? Power is work done divided by time. This is the formula of power. So here what is work done? W, that is here is mgh. Here g is acceleration due to gravity, which is equal to 9.8 and we take approximately equal to 10. Here mass is 40 into 10 into height is 4 meter, which is equal to 1600 joule. This is work. Now what is power? Power is work done 1600 divided by 10 to which is equal to 800 watt. This is the power of a child when run up a flight stair of 4 meter high in 2 seconds. Calculates his power. His power is 800 watt. Our next numerical is a jet engine develop a forward force on the aircraft of 200 kN. What is here force? Force is calculate the power of engine. If the aircraft is flying, we have to calculate power of the aircraft flying with the speed of where velocity. We know that what is power? Power is work done divided by time. And here given velocity is 720 kilometer per hour. First of all, convert this kilometer per hour into meter per second. What is velocity then? 720 into 1000 divided by 3600. 36 ones are 30, 6 2s are 72. Here velocity is 200 meter per second. We have to calculate power. We know that the relation of power in term of force. Here power is work done. What is work? Work is force into displacement divided by time. Where displacement over time is velocity. That is equal to force into velocity. Here force is Newton multiplied by velocity is 200 meter per second. Then power is 2 2s are 4 into 10 raised to power 1 2 3 4 5 1 2 3 4 5 6 10 raised to power 6 watt. This is the power. I hope these numerical are clear to you. Our next numerical is a man of 60 kg jump a height 1.0 meter. What is potential energy of a man at highest point? A man having mass m that is equal to 60 kg jump a height where his height is 1.0 meter. What is the potential energy? What is potential energy? We know that potential energy is mg at its highest point given by what is m? 60 into g. Let g approximately equal to 10 into 1 which is equal to 600 joule. It is our potential energy. I hope this numerical is also clear to you. Our next and last numerical of this video is an engine of train has to apply a force of 4000 Newton to overcome a friction to run at a uniform rate of 60 km per hour. Calculate power. Here we have to calculate power. An engine of train has applied force. Given that what is force is 4000 Newton. Here overcome a friction to run at a uniform rate. Here velocity is 60 km per hour. We have to calculate power. We know that power is force into velocity. And first of all, we have to convert this 60 km per hour into meter per second. 60 into 1000 divided by 3600. 6 1s are 6, 6 are 36, which is equal to 100 divided by 6. 2 3s are 6, 2 5s are 10, 0. Here velocity is 50 divided by 3, which is approximately equal to 3 1s are 3, 16 3s are 48.63 are it 16.6 meter per second. Now what is power? What is force here? 4000 Newton into 16.6, which is equal to what? Here 6 4s are 24, 6 4s are 24, 25, 26, 4, 5, 6, 1, 2, 3, which is equal to 66400 watt. This is our power. I hope all these numerical are clear to you. This is all about work, power and energy, and our unit number 4 is complete, which is work, power and energy. I hope all the key points, all the numerical are clear to you. Thank you and have a nice day.